Hello learners and welcome to this class where we will continue discussing on the management of acidic swells. Remember in our previous class we looked at the causes of acidic swells, the effects of acidic swells and the various physical and chemical characteristics, chemical and biological features of acidic swells. When we were looking at the effects, we saw that they have got various chemical, biological, and physical characteristics that deter the growth of crops and mainly result as a result of fixation of anions and cations so that they are no longer available to crops for uptake. But how is it we manage these acidic swells? There are various ways of managing acidic swells, but the most common is application of Lyman materials. These Lyman materials are mainly used for reclamation of these swells, and they include oxides, hydroxides, carbonates, and silicates of calcium. The most common of these oxides is calcium oxide, calcium hydroxide, calcium carbonate, and calcium silicate, or what we call as the silicate of calcium. But what is it that lime does to the soil to make it less acidic? Lime is dissolved at a slow rate in the soil that contains moisture. That is, a reaction of lime, for instance, in the case of calcium carbonate with water, results to the release of calcium cations, the formation of hydroxide and carbon dioxide gas. The newly available calcium ion then exchanges with aluminium. That is, in the cation exchange, they exchange with aluminium and hydrogen on the surface of acidic swells. What results is that once calcium reacts with aluminium, they form both of the swells. That is, remember in acid swells we have got the aluminium in high amounts, but it is fixed, it is not available. What happens is that when you react the two in an cation exchange reaction, is that both of them become available and they result to the presence of hydrogen. Then lime had produced what we call as the hydroxyl anions. These hydroxyl anions react with aluminium to form aluminium hydroxide. And this aluminium hydroxide then combines with the hydrogen with the hydrogen cations that were formed to result to water. Hence, the aluminium toxicity is neutralized. I want to repeat. Once you add calcium carbonate or lime or any other form of lime, what happens is that the moisture within the soil consists of water, and hence the lime reacts with water to form calcium anions, calcium cations, hydroxyl anions, and carbon dioxide gas. Then what happens is that the calcium cations react with aluminium and hydrogen that result to acidity on surface of acid swells. And what results is that all of them become hydrolyzed despite being previously fixed. So you have got three forms of cations: calcium cation, aluminium cation, and hydrogen cation. And what happens is that the aluminium reacts with the hydroxyl group that was formed in this equation to form aluminium hydroxide. Then the hydroxyl group reacts with the hydrogen to form water. Hence, the acidity is neutralized. When you look at the other oxides, the other types of lime, the case of calcium oxide, once it reacts with water, it forms, just as we have seen, a salt of calcium and aluminium hydroxide, and these can be neutralized using the hydrogen cations and the aluminium and the hydrogen cations and then the hydroxyl group. This is the same reaction for calcium hydroxide and calcium silicate. And these, we are seeing that what forms is that the fixed ions or cations that are useful to the crop, such as calcium and magnesium, are released so that they are available for crop uptake. But what are the solubility qualities of lime that make it a good conditioner to help in making soils that are acidic more towards the neutral side? Lime usually becomes soluble slowly. It solubilizes slowly, and the particles are finely ground and neutralize the acid soils. Another reason why lime is good is that very small changes in the size of particles have a major effect on the time required to dissolve them. What I'm trying to say is that when you're trying to condition your soils from being acidic using lime, is that you have to ensure that you do not disturb the soil so that the particle sizes do not change. Then the effectiveness of the liming depends on how pure or how finely ground it is. If it is finely ground, the better. If it is pure, the better in its effectiveness of neutralizing acids. Then you will also see that liming eliminates the aluminum toxicity and the hydrogen toxicity through its reaction with the hydroxyl group, as I have demonstrated in the equation. The excess hydroxyl group from the lime usually will raise the pH, and once the pH is raised, the soils become less acidic. Another benefit of liming is that it adds a supply of calcium and magnesium cations, making them available for crop uptake. And remember, these were some of the examples of the micro and macronutrients we discussed in the first class, that they are useful for the crop. What are the benefits of liming to the roots? And this is a demonstration of a root before liming and after liming. And what you see here is that after liming, the root becomes elongated. And once it is elongated, it is able to access as much nutrients as it can, compared to a case where it is not limed or it is affected by acids. And remember, the roots are what is important to a crop in terms of uptake of nutrients that help in the processes of crop production. This is also another photo demonstrating how liming affects crop roots. This is an example of a root that after liming and before liming. You will see that the roots are, in this case, are very deep, and they are able to access nutrients or improve the soil structure compared to a case where they are not limed. This is also another case of an experiment showing that as you increase the process of liming, so do the roots become deeper. Another demonstration showing that liming helps to improve the roots, or the orientation in which the roots take during growth. What are the effects of overliming? And I repeat, as I mentioned, you have to do everything in a balanced approach. If you have to increase the soil pH, you do not have to use excess liming. You have to do considerable liming based on a soil test. What happens is that if you add a lot of lime, is that you get deficiencies of iron, copper, zinc, phosphorus, and potassium. And the increment of hydroxyl ions also cause injury to the roots. The overliming also results to boron deficiency. Remember, we had boron last week when we were looking at soil salinity, and we looked at the effects of boron on the soil. Then, too much application of lime also increases the pore space in the soil, and this leads, if it increases the pore spaces on the soil, it increases the rate at which water infiltrates, and hence the water holding capacity of soils is diminished. Another approach in which we can use to ensure that the acids in our soils are reduced is use of crop residues. Crop residues, especially from chickpea and canola, these are some kinds of legumes. They are very effective in reducing the acidity of soil. And this acidity results from the ability of these crop residues to increase mineralization, that is, the ionic formation of the various micro and macronutrients, and they also have a potential to increase alkalinity. They have got alkalinity within themselves. So once they introduce alkalines in soils that are acidic, the neutralization process is able to occur. And this is an example of some of the crops that can be used to manage crop residues that can be used to manage acidic soils. In the case of chickpea, they have got an alkalinity level of 150 moles per kg, and you can see this is in high quantities compared to canola and wheat. And this means that the potential of chickpea and these others is very high in reducing acidity due to the presence of their ash alkalinity. Also look at their calcium nitrogen concentrations. Remember, we said that the presence of ammonia, nitrogen, ammonia and nitrogen also leads to the process of acidification. But when you look at these crop residues, they have got high levels of carbon compared to nitrogen. Hence, they are suitable for acidity elimination in crops. What happens is that the crops also increase the levels of magnesium. And once the levels of magnesium are increased, their variability, they are able to be uptaken by crops, and they are also very important micronutrients. There are also other crop residues that from a localized level, according to this study, the Karongi, the Lusizi, and Musanze, they can be used in terms of to ensure that soil acidity is eliminated. But what I am trying to put in point is that crop residues can also be added, but there are specific crop residues that can be added to ensure that soil acidity is eliminated. Another approach in which we can use to neutralize soil acids is by use of animal manure. And there are 5 types of animal manures that can be used. It could be rabbit manure, swine or pig manure, goat manure, poultry manure, and cow manure. And I'm sure you are familiar with all these kinds of manure. But what happens with organic manure is that it is able to mineralize calcium, ions, and so they are released in their ionic form. And once they are released in their ionic form, they form what they call as calcium hydroxide. And this calcium hydroxide is able to exchange with aluminium so that all these ions are available to the soil are available to the they are available to the soil for uptake by the plant. But when you look at these kinds of animal manure, look at their levels of calcium and magnesium. One of the advantages of using these manures is that they are also able to increase the levels of calcium and the levels of magnesium. Remember that we said one of the chemical characteristics of acidic soils is they have got low levels of calcium and magnesium. So by adding manure, you increase these levels and you are able to eliminate the acidity. Also, the use of pig slurry, or what we call as pig waste, is that it also alters the acidity of soils because it is able to ensure that soil acidity is eliminated to a depth of 8 centimeters in the earth dictated in this study. But I also want to warn you when you're using animal manure is that the biggest challenge we have in using animal manure is that with time, animal manure goes through the decomposition. For example, in the case of chicken, like in chicken manure or poultry, what we are referring to as poultry manure, by the end of 1 month or 30 days, the poultry manure has undergone through the process of decomposition and is no longer available. Hence, its ability to consistently provide these nutrients is also limited. So you have to keep adding and adding, but do not put in excess. Remember also in the case of slurry or human or the waste, the raw waste, if you add it in excess, it is likely to cause nitrogen toxicity to your crops or to your soil. Therefore, in any addition you do, whether you are using crop residues, you are using lime, or you are using animal manure, you have to do it at considerable levels. Usually what pig slurry does is that it increases the pH and also promotes the availability of calcium and magnesium so that they can do the exchange reactions with aluminium. There are also other natural sources of, natural sources of neutralizing acids, and a case example is what we call as nitrate leaching. And nitrate leaching is done by the use of deep-rooted perennial pastures or deep-rooted crops or plants. And what they do is that the deep-rooted plants ensure that nitrate leaching occurs, and they also increase the surface pH of soils, which goes a long way in eliminating its acidity. But now here brings us to the point, how do you know that I am growing this specific plant in this soil? What if the soil is acidic? What reaction will it have? We have got crops that are highly tolerant to high levels of acids. Others are slightly tolerant, and others are moderately tolerant. When I mean that they are highly tolerant, they will survive in acidic soils and crop productivity will not be affected. When I say that they are moderately tolerant, is that they will be severely affected by the presence of acidity in soils. Remember when we were talking about the causes, we said that there are some causes that are natural. That is, the soil right from the parent material is already acidic. So if in that case it is acidic and you know it is acidic, the best thing to do is to grow highly tolerant crops. And these are examples. If you know that the soil has become acidic and some of the crops that you are not supposed to grow are like these examples. And therefore, in this case, you need to use either soil conditioners, crop residues, or what we have said as animal manure to ensure that the soil is well conditioned and the acidity is neutralized. Therefore, in conclusion, what we can say is that soil acidity is a very serious land degradation problem. However, there are various practices that can be used to improve it. These include the use of soil conditioners and ensuring that in these soil conditioners, particularly the use of fertilizers, we discourage the use of ammonia or phosphorus-based fertilizers. And in this case, I'm referring to the case of what we commonly do in this country, the use of DAP, diammonium phosphate, and the use of CAN, calcium ammonium nitrate fertilizers, because they encourage the presence of ammonia and the presence of phosphorus fixation, which is a very serious problem with regard to soil acidity. For you to know this, I go back to the basic. For you to know if a soil is acidic, you have to do a soil test. For you to know that you have managed the acidity through soil conditioning, the use of crop residues, or the use of animal manure, you have to do a soil test. So the basics go back to every modification you do to the soil, you must do a soil test to ensure that it is working or otherwise. Thank you.